Hello, and welcome to our submission for Chainlink's 2022 Spring Hackathon. Weavechain and Shakudo have partnered together to showcase how easy it is to publish complex chain analytics back on chain in real time with a small amount of code that leverages our products. In this case, we're going to pull down information about a few Uniswap pools, calculate the Hurst exponent to detect momentum and mean reversion trends, and publish that data back on chain through a Chainlink oracle. Our goal for this hackathon wasn't to showcase a fancy calculation, though. We wanted to demonstrate how using these tools can dramatically reduce complexity so you can focus on solving problems with rapid analytics to be a Web3 hero. Shakudo is a data and compute platform that makes it easy to deploy machine learning pipelines and do Web3 development, offering access to a wide variety of Layer 1 and Layer 2 nodes. We'll use Shakudo's control plane to handle the orchestration of a variety of infrastructure components and for easy access to their ready-to-go Ethereum node. Weavechain brings enterprise data to Web3, giving it Web3 features and accessibility. We'll use it to give our calculation stream Web3 security properties and lineage, and to easily deploy our smart contracts and Chainlink components. And of course, Chainlink is the oracle that's providing on-chain data access. Let me give you a brief overview of the process before we shoot it to you live. We'll start with an empty Shakudo control plane that is conveniently connected to an Ethereum node that Shakudo runs for its clients. We'll launch a session with an interactive Jupyter notebook and write our fancy analytics function that reads Uniswap pool data from the Ethereum node. Then we'll launch a Weavechain node using a single line of code with Shakudo. We'll configure it to store the calculation feed in a database, and Weavechain will establish Web3 immutability and lineage by hashing that data to a blockchain. Then we'll start pushing the data feed into Weavechain from Shakudo. Weavechain will deploy our Oracle smart contracts and publisher with a single function, and then we'll show you a smart contract consuming that data right on chain. Let's start by getting that Shakudo analytics system going. Our empty Shakudo control plane is already connected to a variety of L1 and L2 nodes, and in this case, we'll be using the Ethereum node that you can see analytics on here. We'll start a new basic session, and all of the code we've checked into our repo will be there automatically. The function for calculating the Hurst exponent is simple. The code for listening to the Ethereum node for order flow from Uniswap pools isn't that bad either. This is what we want people to be focused on when they're doing blockchain analytics. The problem is that deploying the components required to run this code from scratch is miserable. Weavechain and Shakudo make that part easy. First, Shakudo gives our environment access to a running Ethereum node. We list out the contract addresses for the pools we want to watch, and create a new thread for each pool and do our fancy calculation live with each update. Now, let's launch our Weavechain node. Here again, Shakudo lets us easily launch a Weavechain node with a single line of code. And we can see that node initializing in our Shakudo dashboard under Services. We'll launch the Weavechain interface, connect to that node, and define a database that will store the feed data in. And now, we need to start feeding our data through Weavechain. We'll adjust our computation code to initialize the session with a Weavechain node, logging in with a private and public key that has permissions to write to the node. And then we'll publish our computation to Weavechain each time after it's measured. What's awesome is that Weavechain gives the data immutability guarantees by storing hashes of it on an underlying blockchain, and gives it lineage information by storing who the writer is. Now, let's start the computation feed. It connects to the Ethereum node and then starts calculating our Hurst exponent in real time. And we can see that data in Weavechain being written to the database. Now, let's get that data on chain with Chainlink. Weavechain makes this as easy as calling a single function. We'll specify Chainlink as our oracle type with parameters like the Chainlink fee, as well as our target blockchain and our Weavechain data source. When we call the function, Weavechain handles all of the necessary deployments, including the smart contracts and endpoints required to make the feed available to the Chainlink network. We can see the contract is deployed on Etherscan, and then we can fund it with link tokens. Now, the data is available on-chain in the smart contract, and our sample consumer contract can check it and use it for its logic. And that's it. We did it. We successfully established an on-chain data feed based on complex chain analytics. Shakudo helped us easily get access to a live Ethereum node, let us launch Weavechain with a single line of code, and made it easy to create and feed out our fancy calculation. Then Weavechain made it easy to deploy our Oracle system to get our data back on chain and ready to use. I want to say thank you to every person and company involved in this effort. Yevgeny, Stella, and Christine from Shakudo were incredible to work with, and we love how easy and powerful Shakudo's control plane is. Ioan Moldovan is the co-founder and CTO of Weavechain and the magician and architect of this effort. I'm Omar, the co-founder and CEO of Weavechain, and at Weavechain, we make it easy to bring your data to Web3. And last but not least, thank you to Chainlink for being a fantastic Oracle solution to help us on that mission. We've had a blast participating in this hackathon. Please feel free to reach out to us at the emails listed here and in the description for more details on how you can use our tools to help you be a Web3 hero.